Hi, Chitika.
Oh, I was talking and I don't think I'd given my browser permission to use the mic. I was just saying, good afternoon. How are you all doing?
Well, we got you now, Drew.
Awesome.
Good. How are you?
Good, how are you?
I'm pretty good. I don't know. I feel like someone's running around with their hair on fire, but aside from that, pretty good.
Well, good.
Yeah, I guess it means I'm gainfully employed. I should be thankful.
Yeah.
Uh, so yeah, we'll give folks a little while to join. And I'll see if Yogesh is joining, and if not, um, I do want to talk about a few topics today. One of the things we haven't gotten back to is um, air injection, and what does that look like? So um, maybe we need to think about that a little bit more. Okay. I'm going to go look and see if I'm just going to make sure Yogesh is planning on being here. Does anyone know if Yogesh, oh, I'm sorry, Yogesh was missing?
Looks like he just joined.
Oh,
Hey.
good. Oh, yeah, and the other thing is we have this little OCP summit coming up, and we need to look at our slides. Hey, Yogesh, I was just trying to think about what do we need uh, to work on today.
Yeah, so I think you are right. We did talk about discussing slides, but to be honest, I think we can look at it, but I was going to redo some of them. I think the slides that we have right now are okay. I mean, we basically at a high level, we're just talking about what we did, contributions, and what is next, error injection. That's
Okay.
really highlight, but I think I wanted to do, I didn't get a chance to do it, but I think we can probably review our offline, if that's okay.
Sounds good. I mean, I would like to work on, or well, I want to make sure we're on track with the memory one in particular, that fleet scale memory fault management, because I think we were
I think
missing some.
those slides I have pretty much ready except for a little bit of stuff. So let me try to share those. Those are almost
That would be
ready.
good. Yeah, that would be good to review. The other thing is, we just came out of a GPU meeting, and we showed the slide that I had that showed all the efforts fit together on the drawing, and I wanted to talk to you about that and make sure we have some picture like that in our overall the overview deck.
That would be good exercise. That's another thing I was trying to work on with Antonio also. He's not here, but yeah, that would be great. So let's get started. If there are no opens, I can start sharing the slides that we have for the FMFM.
Sounds good.
So, Yogesh, there are two opens. One is something we discussed last week regarding PCIe error handling challenges and improvements requirements. So we need some home for that discussion. And the second point is that the drawing that Drew has, and we are kind of evangelizing right now, the in-band error management, fault management is not really called out very clearly there. So I think we need a little more fine tuning in that block diagram and a separate work stream to define the in-band fault management requirements.
I agree with you. It's barely even considered in that drawing because I don't know what it is. So I think if you could define it, I think what you're saying makes a lot of sense, Anil. We just,
Yeah.
if we knew what to put there, then we could put it, but I don't know what to
Yeah.
put there.
No, I
So-
would like to make a first cut in modifying the drawing. I mean, your drawing is perfect, Drew. Okay, we just need to overlay and clarify the in-band part.
Yeah.
So fine tune it further.
It's not controversial.
Yeah.
Okay.
Yeah, no, I think those are all good points. So let me just sum it up. The second point first, about in-band, Anil, there are two things, right? Yes, we need to highlight it in our efforts and identify that as an effort. Regarding whether it's going to be a separate work stream or work within our project or FTI cloud service model, I think John has clarified many times that that's up to the leadership of the hardware management project. So we can put up our case and then see what happens, right? And I know you have been working with you and Scott are participating in FTI CSM meetings also. Does it
Well,
sound good?
I guess I also thought John said we need to make a proposal and then we run it by the hardware management group and they decide. But
I think that's what CSM is doing. Anil, is it not happening?
No. So let me clarify, right? This team today, what we have been talking for the last 3 years, right, is about fault management. For the last year or so, we kind of have zoomed into out-of-band management that Drew has been driving, but that doesn't mean that in-band is not part of this core group. So in-band
Yes.
and out-of-band both are part of this core group, right? Because there's a lot of synergy. If you look at this drawing that Drew has, right, the right-hand side, the cloud provider infrastructure is common, whether it's an in-band or out-of-band.
I agree with what you said, yes. But I think is the
In fact, the reason I'm saying, sorry, I think we are giving a kind of an incorrect message to the industry that this working group has changed the charter to just focus on out-of-band only, which is
actually no. I mean,
incorrect.
I would say on the contrary, we've been clarifying that we are currently focused on out-of-band, but we want to work on in-band next. And we also said that we are collaborating with cloud service model to avoid overlap of efforts. And one of the things that is expected to happen as cloud service model comes out of future technologies initiatives, I have, along with John was on the call, we have asked them to submit that proposal where they're doing a lot more than just error reporting, right? So or fault handling. So for them to find a house, I think part of that effort, their effort lies in our work group. So we are not saying no to in-band at all. We are not being out-of-band focused only at all. But I think there's a little bit of logistics and alignment issue where hardware management and IC.
So just make sure, just make sure that message is clear in our communication in this OCP Global Summit and our collaterals also. I don't know, somehow it is not coming out very clear to me.
Okay. So let's plan on putting let's plan on making sure that we review that part explicitly, and it's clear, because that's never been intention to just do out of band stuff and not focus on in-band at all.
Correct.
Yeah, I'm strongly aligned with you, Neil. And so the only thing I wasn't prepared to do is do the leading of it, because I think we need someone like you to do more of the driving.
Sure. Yeah, you can put me for the in-band hardware fault management requirement initiative. And the one of the presentation that I've signed up to demystify the in-band versus out-of-band, probably the starting point.
All right. Now the second point is the first open that you brought up about PCIe. I'm not entirely sure what was the plan, or did we ever have a plan on how to tackle that?
I actually have a proposal, if that's okay. We're in the process of evaluating how we want to signal errors and what we want to do for the different classes of PCIe errors. And at the end of the day, this is not anything we're going to differentiate ourselves on at Google. We just want to run OSs and run VMs, and we want PCIe settings that aren't controversial and that don't swamp us with SMMs or NMIs or something because we had a bunch of URs from a driver that did something silly. So, what I'd like to see is maybe make a sheet and say, here's how we want PCIe errors to be handled for each error at kind of a high level for all of our OSs. And I don't want it to be anything magic or special. I just want it to be basic. But I don't know. Is that consistent with what you were thinking, Anil?
Yeah, I mean, at the very high level, that is, first of all, clarify the problem statement, right? There are some gaps in the PCI error handling today. And what is our strawman proposal, which will drive then some changes in the, let's say, PCI spec, ACPI spec, right? There are few existing specs will need some fine tuning.
And Neil, it may even not be, I mean, I'm certainly open to that, but I guess some of the pain points I'm seeing are just that the spec is so stinking wide open that we get these settings that don't really work for our OSs, and they're perfectly legal PCIe settings. And so,
Exactly.
I think I like what you're saying, but I think there's also just how do we use the spec as it's written and say to BIOS vendors, here's how we want to set up the machine when it first boots and how we want errors to be signaled. And then we can.
Sorry, Drew, I'm sorry, I interrupted you. Please continue.
Well, I guess I don't do anything magic. I just want to do something really basic there. And then if we want changes, we can certainly discuss those. I'm fine with that.
Yeah.
I was just going to say that I'm a little confused about what would be OCP's role. I mean, it's either there is a problem with PCI spec, or this is how you understand the spec and configure your system.
I think the way I would put it is there are PCIe pain points. Yeah. Let's identify those pain points and solve them. And so maybe that is the next step, that Anil and I can put down our PCIe pain points. And if someone else has some, I'll start a Google Doc and share it with you all. Put your PCIe pain points.
I think I agree with you. Like, even we are doing some internal PCIe thing. We can, once we have the document Drew and Anil, we can add some of the points. Okay, especially coming from like a lot of IO systems, like with GPU devices and all, right? Okay, the scale of thing with FPGA and GPU devices, the PCIe become a bigger problem. And like if we have some draft one, we would like to add some of the pain points.
Is that okay, Anil, if we just start a pain points document and then we prioritize the pain points and solve them?
Yeah, absolutely. That's the right thing to do. Yeah.
So Drew, maybe I just want to make sure. I guess I'm with Yogesh trying to understand the scope. I mean, it sounds like what you're looking for is to sort of agree on a best known config for, PCIe error handling, right? And the document would be, here's the recommended, BKC for PCIe errors.
Yeah. I mean, that's what I was saying, but that's my pain point, right? And so if we do the pain point thing, that'll be my pain point. You understand me perfectly well, so, as usual, Vilas. But maybe that isn't the priority. So let's throw out our pain. Let's put our pain points in the doc and pick the ones that we need to work on. But that's my.
I think that could be a good white paper.
That's a North Star. I think I agree. That's our North Star, right? If we can achieve a clear best known method, how to configure the PCI error handling, that would be the perfect thing.
And I think the other thing we will find is that, like out of band, it's kind of hard to log some of this stuff. And even in band, some of our PCI experts inside Google have said, gosh, we'd like to have some counters, we'd like to have some data here. And so, as we figure this, maybe getting the OS working is the first step. We have like a known good set of settings across us that say, if you do this, you'll work with most OSs, almost every OS. And then the next step would be, okay, and now how do we improve the diagnosability of these PCI errors that we've configured correctly, but now we got to fix them.
And I mean, Drew, I think you'd also want to write down, for each config, here is the expected, I'll say system response, right? But there's a lot of details in that. And the reason, part of, I suspect, what's going on is that there's variation in, SOC by SOC or device by device variation in like how they deal with some of these things, right? And if you sort of write down the assumptions, then everyone can go and look and say, oh, well, we don't do that, so maybe we can go change our hardware to do that, or whatever, right?
Yeah, exactly. And like just as an example pain point, we had URs that were signaling NMIs. We had a driver that did something wasn't supported. We had a UR storm, which became an NMI storm, and that does bad things to the OS. And those of us looking at it were like, what do we want to do with URs? Well, that's not special. Like, everyone, we should just have a plan for URs that is consistent, I mean, right?
Yes. Yeah. Right.
So anyway, that's my mentality is let's just find something that works for folks, and then we can do better error handling on top of that. I'll start the doc, share it I'll put it in our shared drive, share it with you all, and it'll just be an open doc and people can add stuff to it. And I'll add my pain points too. Okay, well, thanks. All right, and then the other thing we need to pick back up is error injection too. That's what I was saying.
I was going to say that. So, Drew, we have three things we need to figure out how we're going to work on all three. There's error injection, there's PCI, there's in-band, right? So, yeah, we'll have to figure out some kind of, schedule to kind of alternate between the three.
Yeah.
Right?
Yep, I agree.
Sounds good. I'm happy that we are addressing some opens on the spot. That's very good.
We have a target-rich environment.
All right.
I see some new folks on the call today. I don't know if they are new just to me or.
Oh yeah, I should have asked. Emma, you want to introduce yourself? I know you, so I didn't think.
Hey Yogesh, hi. I'm part of Oracle right now, and working on RAS aspects for our OCI ecosystem as well as the on-prem Exadata ecosystem. So I was meaning to participate in this meeting before, but something came up. So now I'm planning to more consistently join this forum.
All right. Thank you for joining. This is great. It's great to have you.
Thank you.
I see Brian Byron. I'm not sure. Brent, this is the first time you're joining, or?
I've been quietly joining off and on here. I'm from Micron in SSD, actually.
Nice.
system architect.
Thank you.
And I think John is new here, which you're one of my favorite people to work with.
Yeah,
but
who is John? I don't know.
I know, it's John Holm.
I know.
Yeah, I'm not sure why I'm here, Drew, actually, but
Okay.
I think Yogesh put it on my calendar, and so I was curious as to why Yogesh did that. So I thought I'd show up and see what you guys
I
were
can
discussing.
explain, John. I can explain because OCP switched from GoToMeetings to Zoom.
Oh,
I want you to catch the link. Yeah.
okay. Yeah. Okay. So yeah, I'm curious to see what's going on. I know about half the people on this call. I think I've worked with. But yeah, I'm one of the SOC RAS architects at Intel.
Welcome.
Anytime you'll show up in the meeting, it's good with me.
Okay.
Ewan Pearson, I don't know if you have been also attending calls before.
Yeah, I've been on these for about 6 months, and yeah, I'm on Tony Geidel's team at Micron, so we're helping out with the memory fault management side of things. More active in the FM part of this, but
Got you. Thank
been
you.
joining this one too. Yeah.
Welcome, team. Is anybody on this call new? I think that's about it. Good. A lot of activity, a lot of interest in this topic, so I appreciate. Yogesh, let's go. Yogesh, are you there?
Yeah, I'm just sharing.
Okay.
Okay. You guys can see. Can you guys see?
Yep.
Okay, so this is our first slide about the work stream. Spun from hardware fault management, focus on fleet issues within the framework of hardware fault management requirements, the goals, methodology, participants. Okay, should we move on? So what we did this time was just to set the stage. We invited comments from various participants and industry stakeholders. So first one is first slide of views is from SK Hynix. These are their comments. Then, yeah, let you can read this.
So this is in general DRAM, or this is specific to, like, say, DRAM, DDR4, 5, LPDDR? I mean, any kind of specific technology, or just generic?
So I think we're starting with DRAM DIMMs, but we have talked about we may expand it into other areas if the need arises, and we feel that's the right thing to do. Right now, we focused on most high volume memory, highest volume memory.
Which is DDR4, DDR5.
The next one comes from Micron. Thank you, Ivan, for sending this.
Yeah, no problem.
And we have a placeholder for Samsung next. They are going to send it sometime soon, I guess. Haven't received it yet. And then some comments from Google are here. I invited comments from others also, but I think if I receive it, I can add. But I think this kind of sets the stage that, yeah, there's enough. This is a common problem that requires a common solution. So then we get into what activities are we undertaking right now? We're creating.
Sorry. Hey, Yogesh. Sorry, can you go back? Sorry,
Which
what
one?
is that? The first bullet? I'm just struggling trying to understand the first bullet. What does it mean? Google internal evaluation found 0.6 precision counting memory errors. Like, sorry,
Do you know what precision? You know what we mean by precision, don't you?
I do.
Is it just hard to comprehend that it's not bad?
No. Well, that's part of it. Okay, okay. You found 6% from counting memory or by counting memory errors. Okay, that was the. I got it now. Sorry, I read precision counting as a phrase. Okay.
Oh,
Yeah, I can see that too. Yeah.
Yeah.
We put the word when counting errors, memory errors in there or something. But yeah, so this is my comment. I can get 3 orders of magnitude improvement in precision by flipping a coin when I get a corrected error.
Yep. No, I got it now. It was literally just it's putting some sort of preposition in between those 2 words will help me a lot. So
Yeah. No, that's good. Fresh eyes. The fresh eyes are awesome. Thank you. So can you just say when? Put a when. Just type when where the cursor is, and we can clean it up. But that's basically the problem. And it is tragically bad. So when someone comes to me and says, leaky bucket counters are the centerpiece of my RAS strategy, I'm thinking in the back of my head, 0.6% precision.
So I'm glad that you put Google logo here, because this is Google specific view, right? Not the overall industry view.
Right.
Because we don't agree with that.
That's great. But I'd love to see what you found. Basically, I've been told over and over again, oh, you can't predict memory errors, and we could, but it was from counting. Now, Anil, what I'm saying is when I'm saying counting, I'm saying all I'm doing is looking at a count of corrected errors. That's it. And the problem
point I want to clarify is that I think your message is very strong here, Google. Drew. 0.6% precision means literally 0. Right?
Yes.
But that's too strong. I think there are challenges in just counting correctable errors under certain kind of fault conditions. But in general, if I want to detect, let's say a DIM with a DRAM with a stuck error, then I can find that by using simply counting errors. I don't see any problem.
But the problem is a single stuck bit. So if you look at the paper that Vilas and I did for, what was it? I forget, it was a conference last year. There's a paper we published. Most memory errors are single stuck cells. And that's what you're going to count. And they're not going to crash you.
And that is pretty precise, right?
Yeah. So maybe, Drew, I guess when you say 0.6% precision, is this in like predicting future uncorrectable errors?
Yes.
Okay, that is a different question.
That's an important point to put on this slide, right?
So that's a very
I guess what I would turn around and ask is, if you say I've got to replace a DIM that has consistent corrected errors but never crashes me, I would say, well, then why are you replacing it?
And right, I don't think we're disagreeing with you, Drew. I think it's important for the comprehension of the slide to say precision in what, right?
And so when we say precision in predicting crashes when counting memory errors.
When only counting memory errors.
Yes, only. And again, and that's right. Counts are useful for understanding your sample size when you look at patterns, but they're not useful by themselves. And, I've had conversations with SK Hynix and others. Roy will be the first to tell you counting memory errors doesn't work. He'll nod his head. I don't know if he has the same number, but basically, I only want to replace a DIM if it's going to cause a crash or a performance problem.
Okay, so performance problem, Drew, I think is a pretty big nail. A big statement you made, right?
Sure.
So let's say if I have a multi-bit failure within a DRAM device, okay, stuck faults, they're all correctable, right? I can keep correcting, but there is a potential performance impact.
Well, if you're talking about implementing recovery,
No recovery. No, these are all correctable, right? There is no uncorrected.
oh, they're all corrected.
Yeah.
So whether it's single bit or multi-bit is irrelevant. Then, I mean, it costs the same in terms of performance. It's really how much of your DRAM, what portion of your DRAM is causing corrected errors, and what is the impact of a corrected error to your performance? Are you taking an interrupt for it? What is the impact in the memory controller and the reorder buffer and rescheduling?
The point I'm making, Drew, is that whenever there's a persistent fault or permanent fault, whether and I agree with you, whether single bit or multi-bit within a DRAM device, right? Even though they're all correctable, as long as we can count them, regardless of what pattern it is, and if once it's a permanent fault, we can detect it through the count at a rate and do a trigger remediation.
Right, and do you really need
precision is pretty good. Precision is pretty good.
Do you need to?
Of course.
No, you don't. Why?
Yeah. Because performance impact, right?
Are you sure?
Of course. We have a lot of signals in our fleet that detects those stalls. We call stalls, okay? And for various reasons. I mean, one was SMI, which we resolved that. So that's
well, but I want to clarify something. Meta did a presentation on their SMI handler, and you were using IPMI to send things to your BMC. There was a handshake with the BMC and the SMI handler.
Yep, we solved that, right? And so that big bucket of stalls went away. And now we are opening up for other types of stalls due to just sheer the permanent fault causing lots of events, interrupts that are not needed. Sorry.
You're taking an interrupt for every memory error?
No. What I'm saying is we can detect those, right? And we do trigger a remediation because we don't want those DIMMs in our fleet.
To do what?
We don't want those DIMMs in our fleet when there is a permanent fault. Anything right now, actually, even a single bit permanent fault, we are going to take the DIMM out. I'm right now pushing towards single bit tolerated. At least once we see a few more bits failing in a DRAM device, then trigger a replacement.
Well, and I think the important thing there is, so I think we're aligned. And what I would encourage you to do is look at the percent failures where you're replacing parts where the failure ended up being a single stuck bit. If you can gather enough data to look at the pattern and just look at that and see what you see.
Mm-hmm. Yeah.
Because you might find, then that'll be informative because then we can figure out, okay, what really causes the performance impact. Now, if you have, if you're sharing something critical across a large number of threads and you're using a cache line that happens to have a stuck cell, I think you could end up, contriving a situation where you have a performance problem. But honestly, the odds of a single stuck bit, causing that performance problem are infinitesimally small.
Yeah.
So can I ask you a question, Anil? I mean, I read this and I say, well, Google's asking for more information about each error that it sees. You would use that too, right? I mean, you would, you like, the syndrome and address and all that stuff too. I mean, that's all useful stuff. I would guess for everybody.
Yeah.
Is that true?
Yeah.
Or are you just saying counters are enough and we don't need to do more than counters? There's diminishing returns post counting.
No, that's not what I'm saying.
Okay.
I just want to make a comment that the bullet calls, it sounds like just by counting error is useless.
It is.
And that is not true. That's all I want to say.
Well, it sounds like there's like some performance cases, right? Where if you're counting errors and you see a billion of them a second, that's gonna, even though there's no functional problem, that's a performance problem. I could see there are some exceptions to that, but
I mean,
this is really trying to motivate, give us more information about the failures, right? Than just
yeah.
counts.
And
I
for the
I just think
purposes
it's a
of this,
hierarchy, right?
Yeah.
It's just a
Yeah.
hierarchy. There is a count importance, you know, that applies at one place in the hierarchy, but there's another place in the hierarchy where row and column matter, and you know, and the idea is, and all of them should work together in harmony, right?
Yes,
To me, the count part of it is important up to, you know, because that's probably the lowest part of your hierarchy.
exactly.
That's where you would say, hey, I need to page retire. And ultimately, if you do that and you have a single cell, that error goes away and your box continues to run reliably.
Mhm.
Vilas,
So-
you were trying to say something. What were you trying to say, Vilas? I'd like to hear your opinion.
Yeah, no, I mean, I'll just say it as there's clearly ways that corrected errors can induce performance problems and other problems, right? Like it's pretty easy to set up something that does that. For the purposes of the slide, I would just recommend you focus on exactly what is written, right? Because that's I'll just call it a quantitative statement that I presume has data behind it, right? All the rest of the stuff ends up being, I don't know, subjective and depend, you know, from this memory controller, it's this, for that memory controller, it's that, for this OS, it's this, and for this setting, it's this, right? It gets, there's a wide variety, right? Which is, I think, part of what you and Anil are, you know, going back and forth on, right? So just for the purposes of the slide, it's, I mean, Anil, it sounds like you're okay with the statement as stands, right? It's when the statement gets broader, that's when there's some disagreement, right?
Yeah, as long as it start with Google, right? That's good enough.
Yeah.
I just want to make sure that we are, at least among ourselves, right, are clear that this is a Google specific statement.
Sure. And I guess the other thing I would say is that you know, to do this right, counting, do I really even want to start with counting? I think what I want to do is I want to look at the patterns in memory, figure out what the scope of the damage is in memory so that I know what bits are going to be flipped. And then what I want to do is evaluate that against the CPU's ECC and its particular ability to correct that particular failure mode.
Yeah, but Drew, I wanna push back on you here, right?
Okay.
I understand what you're saying, but you have a very specific, I'll call it set of policy choices in mind when you say do it right. If you made a different set of policy choices, you'd end up with a different answer, right?
Yeah.
So just like it's like there's a way to do it right given a set of policy choices, right? But not everyone has the same policy choices. So just keep that in mind.
Actually, that's true. If you're really focused on preventing crashes, there's a right way to do it. If your policy is broader than crashes, then sure, there's other ways to do it.
But if you're focused, I'll say it this way: if you're focused on predicting crashes and money and downtime is no object, there's another right way to do it. And like I know that most people aren't. Right? I know that most people aren't in that situation, but that's a valid policy choice, right? So just keep that in mind.
Yeah, no, I agree with you.
Yeah, I mean, one
Drew,
thing I would
echo.
clarify.
Yeah, just to echo what was said a little bit earlier, that this 0%, 0.6% precision in predicting crashes. I mean, Micron's internal data, I don't have a number to back that up. But coming back to the hierarchy of information we need from the studies we've done internally, they're, you know, talking about counting. It's not useless for that, but it is like 5th or 6th down on the hierarchy of things we need to know for more accurate crash prediction, potential UEs in the field. So it's on there somewhere, but I don't mind the way that bullet's worded from Micron's perspective. The only counting memory errors, we have also found that to not be helpful at all. In combinations with other things, then yeah, it can be.
Sure, I'll buy that. Okay,
Yeah.
okay.
If
Well, I
I
think
may,
it's good. And I'll be honest here, this statement is really intended to provoke a discussion, which I think it did. So that's good. And it'll get people thinking about, can we do this better? So, even if you don't completely agree with it, at least it'll provoke some thought.
If I may, if you want to clarify, only counting memory corrected errors.
Sure, yeah. I mean that's kind of implied because it's a crash if it's uncorrected, unless you're assuming we're doing, poison recovery.
Yeah, that's what. No, let's make sure we are technically correct here.
Okay.
People don't make
You
assumptions here
mind,
that.
you mind putting the word corrected in? I like it how we're group editing
memory
little
corrected error. Memory corrected error.
Well, corrected memory errors is fine too, either way. I usually call it corrected memory errors, but that's
Okay, that's fine.
If it's my statement, I would say corrected memory errors. That's how
Okay.
That's how I say it.
That's fine. Either way is okay.
Right. Hey, we're still ahead of time. I mean, we are already on 7th slide, which is a lot, including the fluff, but typically this would be the first slide and we'll be 42 minutes into the call. Next one is kind of boring, but I wanted to highlight what are the vectors that we are working on. We are working on filling gaps in logging methods, standardizing the formats, logging parameters, what to log. It kind of sounds like repetition of the first one. I think first one covers the second and third, so I may need to tweak this a little bit. And requirements for the analyzers, and I call it baseline because we have some details later, which we're trying to retain the scope for vendor specific innovation while we do this, right? And abstraction level also talks about the same vector that we're not trying to make everything open to everyone. And one of our aim is to contribute these requirements by next global summit. So we'll see what happens. By the way, on that note, those who were there in last summit, finally we are getting like really close. Something that I wanted to get done in like 2 months, 3 months. We are contributing the hardware fault management. It's almost in the final stages. So thanks all for that.
Well, thank you for the final push, Yogesh. It's been a surprise. Like we did the hard part, and the what I thought was the easy part turned out to be kind of hard. So thank you.
I mean, yeah, we did. You had to do all of it, and there was yeah, it's yeah, it was a great journey working with all on all the different aspects that we tackled, and I think it's pretty good and rich document. So yep, it is good. Looking forward to next one, right? And now on back to this slide, right? What I'm trying to do here is to put FMFM in the context of the broader framework that we have proposed in the requirements document that I just talked about, right? So Drew and I have worked on this pictorial, and we're just highlighting that we are using failure modes knowledge, gathering critical data in what format, and what are we enabling in terms of through isolation, prediction of crash, and automation of last actions. Okay. Any comments on this?
I think you may want to make one statement somewhere here, maybe just verbally, that the fault analyzer we are showing here within the cloud provider infrastructure, but it's not necessarily be only one displays. It could be anywhere. It could be either DMC, it could be even within the platform itself. So this is one example.
I think that's fair. I think my goal has been to do it in the scope of the giant data center, but the analysis could be done other places, and I think that'll be important as you do the in-band work, Anil, to maybe highlight that.
Yeah, exactly right. Yeah, I didn't want to make it very explicit, but yeah, just make a statement, right? That this is an example of where the fault analyzer is located, but this is not the only way to implement.
Well, it's code, and people can put the code where they need to run it. Yeah.
Right.
Yeah. We'll state that verbally, right? So also record it, so should be fine. Is that okay, Anil? You do that verbally?
Yeah, that's fine.
Yeah. I think next one makes it a little bit more maybe controversial, maybe clear. What we are trying, and Andrew, sorry, I was going to discuss this with you in Tuesday's call, but comes to you as a surprise. You've seen this though, but what we're trying to do here is how the analyzers address different vendors. Analyzers address different aspects and as strips out and decodes platform specific information, DRAM specific information, retain the intelligence in encrypted or binary format, whatever it may be, but still use the standard CPER format for relaying the information, and then feed that into analyzers for platform memory fault and further into summarizers for infrastructure. And that can drive repair automation and repair actions back to the platform.
Hey, one thing I would put here, this is the summarizer is kind of an Intel term. That's the name of an Intel analyzer. Do we want to maybe make that generic, like SoC analyzer or something?
I'll check into that.
Do you see what I'm saying? Just the summarizer box. Maybe it's okay to use because it does summarize the error, but I don't know.
Yeah, I didn't think of that as a kind of a trade name, but I'll check on that. If that's a problem, then we can fix that.
Yeah. What's the name we're using on the overall picture for the HW MG?
A vendor analyzer. Or you could SoC vendor analyzer is what I think would be consistent.
Yeah, I mean, I think it's actually important to say something like SoC. I mean, summarizer is fine, right? Or platform summarizer, like something that indicates that it's not just a mechanical thing. It's like it's got to take into account the platform, right?
Yeah.
Right.
So I think that's an important, like, I mean, Carlos, I think that's what you're, oh, actually, wait a minute, hang on. Oh, yeah, you got that part there. Okay.
I think, I was just, the name summarizer, I was worried that was an Intel name. But anyway, you can figure it out. I'm not worried.
Yeah, let's try to be consistent with the, the framework we're showing on the main work group, right? Because this is pretty much a subset of what we're trying to do here, right? So.
I have a question. On the second slide, are we discussing the context of that is runtime error reporting flows? Is there a flow, or can you go to the next slide? I'm getting confused between slide 9 and 10. So in slide 10, what is new? What you're trying to show here? Is there a flow you're showing here, or actual block diagram of where things are located?
This is details about the analyzer. The fact that first we decode the error from the CPU vendor. The memory vendor then says, here's what's broken inside the DRAM. And then the platform memory fault analyzer evaluates that particular failure against its ECC. So this is a good way to predict crashes, because what you're doing is you're saying the memory vendor knows what's going on inside the DRAM, and the CPU vendor understands how well their ECC will tolerate that. So
this highlighted yellow part is going to be located in the cloud service provider infrastructure?
Well, this is just an analyzer. Yeah, this is like one of the analyzers that goes in the analysis tool. It can run anywhere, just like we talked about, but in the picture, it is, in that box on the right.
I'm just having a hard time in connecting the two slides. Sorry.
It's really simple, Anil. But we could maybe make it a little more clear. But basically, because there's no cloud, or there's but basically the stuff on the, maybe we could do, Anil, is put a kind of like a dotted line to the between
So
the.
I think with that and Carlos's point, consistency of the boxes between the two, I think that will help. Maybe we can we do have it dotted somewhat here. Yeah.
In this picture, what I would do is just highlight the memory vendor analyzer box on the right, like in yellow, or the same color you're using on slide 10. And I don't know if it's even worth to have like a smaller picture of this into slide 10 that then just breaks it out and say, this is what we're talking about. This is where it fits, and have an arrow that goes from the yellow box on the bigger picture into this yellow box, and then that connects the two.
Yeah, I'll see what can be done to do that. I think that's a good suggestion, Carlos. Yeah. All right, so yeah, that is basically the last slide that we have, and then we get into call to action. It's a quick 20-minute session, so we expect to invite a lot of questions. I think we should have like 5 minutes saved for question and answer, Joe. Questions and answers. Okay.
Yeah, one thing, Yogesh, is not coming out clearly here is some sort of a timeline of deliverable, or do we have something like that? Some logistics of what we are.
I mean, right now we have this, that we want to contribute requirements by next global summit. This seems achievable. I mean, Ivan and Drew, keep me honest here. This seems.
So this should come out in the last slide when you talk about like a call to action, right? Or maybe not call to action. Actually, you are summarized. No, this is somewhere got stuck in the middle. You need to kind of highlight that somewhere.
Yeah, I mean, we're talking about activities on this slide, so
maybe
I'll think
back
about that.
Yeah, circle back at the end, right? Okay, so we talked about all these things. What's the real thing? What's the real contribution here, right? So this is what we are doing. We are planning to do something like that, right?
And I think the other thing we want to do is, and maybe this is not right, but I kind of get the feeling we're going to have a proof of concept that we're working on, that we can say, hey, we've done some work here. We have some evidence that this is good. Is that accurate?
Just had a quick question, if I may. About the scope for this, I know that you are mainly looking at this from a data center standpoint, but is there any plan to also consider alignment with, say, automotive safety and their platforms and the requirements, for safety critical systems? Is there any, or is that outside of scope?
The problem is that we don't have really good representation there. So, I mean, if there's something they could leverage, that would be good. But I'll have to be honest with you. I don't think I know the first thing about what kind of ECC automotive applications have. And a lot of what we're doing by analyzing errors is based on looking at corrected memory errors from error correction in the memory controller. So I don't think we're opposed to things that people could leverage, but we don't have the right people here to make sure we're covering that.
Mm-hmm. Okay, no, that's fair. I was just wondering, about the scope, and maybe that's something to look at just opportunistically, even if you know, we
I mean,
don't.
if some automotive person wanted to come here and said, yeah, I've got ECC in my car, that'd be fine. But I would suspect that the cars use automotive grade parts that, and not wide, and, you know, do they pay for the extra memory? Do they pay for the overhead for ECC? Because in my experience, you know, the auto companies are pretty cost sensitive. But I don't know. As I said, I don't really know the first thing about it.
Well, the reason I was asking was because I know that, you know, for ASIL-D, the requirements are more stringent than data center, right? And so a lot of those auto-grade components are now being used or being considered even for the data center applications, just because of the level of diagnostics that are, you know, gone into the development.
Oh, that's interesting. I'd like to learn more about that sometime.
Yeah, I agree with that. Auto industry has a much more stringent requirements, especially with these all electrical vehicles where there's actual computers running in the car. It's a much more stringent failover. You know,
Yeah, I mean, I know some cars have ECC, but I don't know about normal cars. Do you all know?
So it depends on the kind of system. So there's different levels of safety integrity, right? From ASIL A through D. And so for an ASIL-D system, that's where, you know, the requirements are really stringent, but for like a regular, like infotainment type application, which you're probably referring to, you know, the requirements are a lot looser.
Yeah. Well, I guess what I would say is we've considered it out of scope because we really don't have critical mass in that field.
Mhm.
But if there was someone who wanted to leverage what we're doing, I, in my dreams, would like to make this as useful to the CPU vendors as possible and to the memory vendors so that they do a really, really good job analyzing memory and make memory reliable. So, you know, selfishly, I think it's great if, as long as we don't dilute the data center effort, but getting better at analyzing memory is nothing but good.
Makes sense. Yeah. Thanks.
Yogesh, there are only a few minutes left. There's one logistic thing I wanted to share. I don't know if you have time.
Yeah, we have 3 minutes. Go on.
Is it a 3-minute topic?
Let me just share my screen. Might be easier. So I just want to clarify that where all these presentations are. And I was having hard time in, so this is our OCP for hardware fault management drive. Yogesh, I think the presentation that you just shared is over here, correct? Fleet management.
Yeah.
Yeah, I think that's one version of it. Yeah.
So maybe you want to give me access, because I don't think everybody has access to this folder. So I was not able to contribute to this folder. So I just created a new
You
folder.
should be able to comment on those slides.
Well,
Everyone who can view should be able to comment.
But Yogesh, we need Anil to have write access so that he can write his presentation into the same folder.
Right.
So what I did is, so one of the presentations that I have signed up for, this is a meta-specific RAS for Grand Teton platform. So right now I just I created a new folder here, and I put the link here. Maybe you can queue up Yogesh for next week. I can walk through this one, and offline if you guys can review it and provide some feedback, that'll be awesome. This is not 100% done, but we are getting closer to that.
Cool.
And Yogesh, once you give me access to this one, then maybe I can just move that link here.
Yeah, it'd be nice if we had just one folder. I agree.
I would rather than rename this one to be consistent. In the past, we always have been renaming, using this name like OCP 20 year, and then is a regional or global, right? And things like that. So just use a consistent name.
Yeah.
Okay. That's it. Thanks.
Awesome. Well, thanks everyone. Happy Friday, and I guess it's time for Vilas's drink and me to dream about it as I get ready to fly home.
Yep. Happy Friday, everyone. Have a good
Yeah,
weekend.
happy Friday. Have a good one.
Friday.
Thank you. Happy Friday.
Thank you. See y'all later.
Yeah.